We're now looking at part B of universal gravitation, which is the math part. So we're going to look at the equation that Newton came up with that explains the way that particles with masses are attracted to each other. So we're going to also apply Newton's law of universal gravitation to solve problems. So as we discussed in the last video, all mass is attracted to each other, and we call this the gravitational force. It is the weakest of the forces found in nature, but it has the furthest reaching effect, meaning it affects things the furthest away with the biggest distance. So we have an equation for this, and you should be familiar with the force of gravity. Now we have a new way to calculate it. So we have this big G here, and this is the gravitational constant. So it's just a number we have that we multiply by things to adjust the force so that it's what we measure it to be. And that number is 6.67 times 10 to the negative 11 Newton meters squared per kilogram squared. So then the way the equation works is we just have the two objects, their masses, that we're trying to see what the attraction is between them. And the attraction, the force of gravity, depends on the distance between them squared. So I want to pause here and point out something, okay? Say we have a block, okay, and then we have a person, okay? If that distance between them is 1 meter, then the force of gravity, we could just say it's Fg at this point, okay? So that distance 1, we square it, 1 squared is 1. Now if we move this person to 2 meters away, and we compare the force of gravity, so this is now 2 meters, r squared is 4. So what we're going to end up with is the force of gravity has now been divided by 4 compared to the original force of gravity when it was 1 meter away. Okay, so this squared here on the bottom means that the further you get away, very quickly the force of gravity drops off in how strong it is. So when we're talking about the distance between two objects, where should we measure that distance between? Do we use outside edge and the outside edge? Or, you know, from the same side to the same side, or the inside edges? Well, it turns out what we want to do is we want to measure it from the center to the center. Okay, and this goes back again to when we were talking about center of gravity. Okay, we can also act as the center of mass. So we always measure distances from the center. So let's look at an example of applying this equation now. And since we're all studying physics and you use your book a lot, okay, we're going to find out what the force of gravity is between you and your physics book. So we're going to assume that a person has a mass of 70 kilograms and the mass of a physics book is 2 kilograms. So if the distance between a studying student and his or her textbook is 0.3 meters, okay, and remember that would be measured from the center, what is the force of gravity between the student and their book? So we've got these three things, and now we got to remember our equation. So it was Fg equals capital G m1 m2 over r squared. So here we've got G. So when we do these problems, if it's asking what is the force of gravity between two things with mass, we need to remember that we can always include in our list of knowns our gravitational constant. So I'm just going to write that here. I'm going to put the units under it just to make things a little simpler today, and so I have enough space to work. All right, so now we just get to plug in all the values that we have. So we're going to have our 6.67 times 10 to the negative 11 multiplied by our two masses, 70 times 2, and then I divide by the radius squared. And if I do all of that and I plug it into my calculator, I get a value of 1.04 times 10 to the negative 7, and this is a force, so we come out with a unit of newtons. So that 10 to the negative 7, right, if we wrote that out in decimals, we'd have 0.000000104 newtons. So it's a very, very, very small value. So definitely need big masses in order for there to be a lot of attraction. But if you were way out in space, you and your book would actually get closer to each other because of this force. So let me know if you have any questions in class, and I will see you there.